Hello everyone. In today's lecture we are going to discuss about the concept of cyclic quadrilateral, and this is lecture number 2. I have already released lecture number 1, okay? And in previous lecture we have studied about the basics to solve the problem related to circle, and this lecture is on cyclic quadrilateral. So let's start our lecture. Our topic is concept of cyclic quadrilateral. Cyclic quadrilateral is a type of quadrilateral which is circumscribed in a circle. Here, let me write here definition. Here definition, a type of quadrilateral which is circumscribed in a circle is called cyclic quadrilateral. It means all the four vertices of the quadrilateral lies on the circumference of a circle. Here, like this. Suppose this is a circle. Then the quadrilateral lies inside is a cyclic quadrilateral if all the four vertices lies on the circumference. Suppose ABCD is a quadrilateral which is inside the circle. Here you can see each vertex of this quadrilateral lie on circumference of the circle. So we can say this quadrilateral as a cyclic quadrilateral. Cyclic means inside the circle, okay? And now I am going to give you some properties of cyclic quadrilateral, right? These are properties of cyclic quadrilateral, okay? Here, first number property, all the four vertices of a cyclic quadrilateral lie on a circumference of a circle. Here you can see all the vertices of this cyclic quadrilateral ABCD lie on the circumference of a circle. Let's come to next point. The sum of a pair of opposite angles is 180 degree or supplementary. Here, according to this second number property, suppose this is angle theta and this is angle alpha, then angle theta plus angle alpha is equal to 180 degree. Then angle theta plus angle alpha is equal to 180 degree. And let this angle be x and this angle be y. Then according to this property, angle x plus angle y is equal to 180 degree. Okay. Sum of pair of opposite angles is 180 degree, means you have to take opposite angle. Here theta is the opposite angle of alpha and here x is the opposite angle of y. So you have to, if you sum this x plus y, then it gives 180 degree. This is one of the property of cyclic quadrilateral. Similarly, let's move to our next point, that is an exterior angle formed by producing a side of a cyclic quadrilateral is equal to its opposite interior angle. Let me draw this, okay? Suppose I produce side BC to T, okay, T, then according to this property, an exterior angle formed by producing a side of a quadrilateral. An exterior angle formed by producing a side of a quadrilateral. Here, the angle is formed. Let this be beta, okay, beta. Then is equal to its opposite interior angle. Is equal to its opposite interior angle. The opposite interior angle of this beta angle is theta. So according to this property, theta is equal to beta. According to this property, an exterior angle formed by producing a side of a quadrilateral is equal to its opposite interior angle. Here theta is the opposite interior angle of beta. Similarly, if we produce this line BC to this side at Q, then the angle formed, suppose Z, then angle Z is the exterior angle and its opposite interior angle is angle Y. So here Z is equal to Y, we can write according to this property. Okay. Similarly, if you produce the side CD to M, then the exterior angle is formed. Let this angle be gamma. And here gamma will be equal to X because its opposite interior angle is X. So here we can write X is equal to gamma. This is gamma. Okay. Similarly, if you produce the side DA to N, then your exterior angle is formed. Let this angle be C, small c. Okay. Then the angle C will be equal to the angle alpha because here alpha is the opposite interior angle of the exterior angle formed by producing the side DA to N. Okay, that is the angle C is alpha. So we can write here alpha is equal to angle C. Okay. Here you have understood about two properties, three properties. Okay. All the four vertices of a cyclic quadrilateral lie on a circumference of a circle, and sum of a pair of opposite angles is 180 degree. Similarly, an exterior angle formed by producing a side of a quadrilateral is equal to its opposite interior angle. And this fourth number property is the basic one that we have already discussed in lecture number 1. Okay. In this lecture also we will discuss about this. Angles on a circumference standing on a same arc are equal. Let me make a new circle. Suppose this is a circle. Okay. Then according to this property, if PQ RS is a cyclic quadrilateral. Okay. Angles on a circumference standing on a same arc are equal. Let QR be an arc. Then if you join this and this, then they form an angle, that is angle alpha and angle beta. This angle alpha is equal to the angle beta because these are the angles on a circumference standing on same arc QR. Okay. So here we can write alpha is equal to beta. Similarly, if we take the arc RS as a common arc, then the angle X will be equal to the angle Y, where angle X is equal to angle Y. Similarly, if you take PQ as a common arc, then here angle A will be equal to angle B. Here angle A is equal to angle B. And similarly, if you take PS as a common arc, then here the angle formed here, that is M, and the angle formed here, that is N, will be equal to each other. Here angle M is equal to angle N. Okay. Your last number properties says that angles on the circumference on the same arc are equal. The angles on a circumference standing on the same arc are equal to each other. These all are four properties of cyclic quadrilateral. If any one of the properties is satisfied in a quadrilateral, then such quadrilateral becomes the cyclic quadrilateral. Okay, this concept you have to use. You have to use these properties to solve the problems related to the circle in further lectures. So here in this lecture we have discussed about the concept of cyclic quadrilateral and the properties of cyclic quadrilateral. We have discussed about the definition of cyclic quadrilateral, what is cyclic quadrilateral, and what are the properties of cyclic quadrilateral. And in another lecture we will discuss the problems related to the circle. Okay, thank you for today.